Hi, welcome to the flipped instructional session for Math 08B in Unit 107, Interpret Slopes and Intercepts. Today, we're going to talk about interpreting the y-intercept of a trend line equation in the context of the collected data. We're going to interpret the slope of a trend line equation in the context of the collected data, and we're going to analyze the equation of a trend line to summarize the given data or make predictions regarding additional points. As always, there is some vocabulary that we need to know and understand moving into the lesson. The first is initial value. We talked a lot about this in semester 1. The initial value is the beginning value of a linear relationship. The initial value is the y-intercept of the line. Rate of change, something we also talked about a lot in semester 1, is the rate at which quantities change over time in a linear relationship. The rate of change is the slope of the line. And finally, the trend line is a line that shows a linear relationship between variables on a scatter plot. This is also known as a line of best fit. So a quick review here. Suzanne is drawing a trend line on a scatter plot. So we just talked about a trend line is a line of best fit, and it's linear. Which of the following is a characteristic of a good trend line? It is horizontal, it has a positive slope, it passes through most of the data points, and it has an equal number of data points above and below it. So the correct answer here is it has an equal number of data points above and below it, as that would show that the line is sort of trending between all of the points, and all of the points have about the same amount of space between themselves and the trend line. Some trend lines can be negative, so it does not have to be positive. Passing through most of the data points can be difficult because remember, a scatter plot, they're just kind of like little dots all over the line that have a general trend. So getting through all of it maybe would look like a line that goes up and down, so that wouldn't be a trend line. And horizontal, that just means straight across, and that really doesn't have anything to do with trend lines. Let's take a look. An economist creates a scatter plot comparing years of experience to yearly salary in dollars at a particular company. The trend line through the data can be described by the equation y equals 4,000x plus 20,000. So these are linear equations which we worked with in semester 1. But now we're just looking at this in terms of real life data on a scatter plot. And real life data on a scatter plot doesn't always fall directly on a linear line, which is why we make a trend line. So this is the trend line. It says, what is the slope of the trend line and what does it mean? So remember, slope we also called rate of change. And if you remember from semester 1, a linear line follows y equals mx plus b, where m is the slope. So if we look, y equals 4,000x plus 20,000, we can see that the m, or the slope, is 4,000. And I put dollars because it says in dollars. But remember, with a slope, it's a rate of change over time. So this is dollars per. So an economist creates a scatter plot comparing years of experience to yearly salary. So dollars per year. So you should always have 2 units when we're talking about slope or rate of change. And generally speaking, the time is on the bottom. So year, days, months, weeks, seconds. So that is our bottom here. And then they told us that the dollars is what we're looking at. So the slope of the trend line. We could just say the slope is 4,000 and that would be okay. So I can say slope equals 4,000. So notice it doesn't say 4,000x. X is not part of the slope, only 4,000. So what does it mean? So in the context of this problem, we're talking about a scatter plot comparing years of experience to yearly salary. So what we can say is the salary increases $4,000 with each year of experience. So year of experience would probably be a better descriptor. It doesn't mean just that you get $4,000. So it's $4,000 with each year of experience. You get an increase of $4,000 per year of experience. And that's a positive 4,000, so you're gaining that $4,000 a year. So we have the same problem. Again, we have the scatter plot comparing years of experience to yearly salary. So this kind of helps us too. Years of experience to yearly salary. So again, those are the two units that we talked about with slope. The trend line through the data, y equals 4,000x plus 20,000. What is the initial value and what does it mean? So again, we have y equals mx plus b, and b is the y-intercept, which is also known as the initial value or initial amount. So in this equation, we see that's 20,000. So that is the initial value. What does it mean? So we need to talk about units here. So this means at 0 years experience, you make $20,000. So $20,000 is the starting salary with 0 years experience or with no experience. So it's important to understand that this is at time equals 0. What happens at the beginning with 0 experience. Okay, let's take a look. The 8th grade student council is running a concession stand on the nights of the school play. They made a scatter plot. So remember, a scatter plot has all little dots everywhere. They're not all right in a line, but they form a trend. They make a scatter plot to compare the amount they earn each night with the number of tickets sold. The equation of the trend line is y equals 12x. Based on the trend line, how much can the student council expect to earn on Friday night if 100 tickets are sold to the play? So y equals 12x. It says they make a scatter plot to compare the amount they earn each night. So here's the amount they earn each night with number of tickets sold. So here's our number of tickets sold is x. So we say y equals 12 times 100. So we get 1,200, and that's in dollars. So we just plugged in for x. Tatiana has some money in her savings account. She decides to add money each week. She creates a scatter plot to compare the number of weeks to the amount of money in her account. The equation of the trend line through the data is y equals 20x plus 45. What can you conclude based on this trend line? Choose all that apply. So we have number of weeks and amount of money. So remember, the time is what we put on the bottom of our rate. Money is what we put on top of the rate. So what is the rate? Let's just talk about the slope is 20, and we just said that money, so that's $20 per week, $20 per week. The initial amount, or B, is this 45, and that's the dollars. So let's look. Does she add 45 each week? Nope, we just said that the rate, what she adds per week, amount of money per week, that's 20. So this is not correct. Tatiana adds about $20 to her account each week. So we see this is a rate, $20 each week. That's what we have, $20 each week. Tatiana had $20 in her account when she started. Well, we just said that B is 45, and that's our initial amount, so that's incorrect. Tatiana had 45 in her account when she started. That is correct. That's what she started with. Tatiana has $65 in her account at the end of her saving. Well, I don't recall. It doesn't say anywhere in here how many weeks she decided to do this. So we don't know how much she has at the end because we don't know how many weeks she did it. So that is incorrect. If we knew how many weeks, we could, if we knew, if she did it for 10 weeks, that is what we put in for X, the time. So we could put in 10 if it asked, if they said that she did it for 10 weeks. So this is 200 plus 45, so that would be 245, would be the total after 10 weeks, but they didn't ask. But that's just how you would go about doing it. Thanks for watching. Look for the flip follow-up session and the help lab in your Class Connect schedule to ask questions. And that will allow you to work further into this topic as well as get more in-depth information. Thanks.